So well, in this case, we are given a quadratic number pattern, 94, 90, 82, 70, and it goes all the way to infinity. And the first question is asking us to determine the next two terms of this pattern. And afterwards, we need to find the general term of the number pattern. And there comes a very nice and interesting question, 4.1.3. So guys, I highly recommend that you pause this video and quickly try these problems by yourself, and then play the video and mark yourself. See if you got these things right. So let's quickly destroy the first two questions before we can analyze the third one. It's very nice and delicious. So this is the pattern we are given. They say we have 90. In fact, it's 94, 90, and they say it's 82 and 70. And this goes all the way to infinity, of course. Remember, we are not finding the general term as yet. We are trying to find the next two terms, right? So it's necessary for us to find the differences because they're going to help us to find the next two terms. So when you say 90 minus 94, you get negative 4. But when you say 82 minus 90, well, you get negative 8. And 70 minus 82, well, you get negative 12. Well, I don't really trust my mental maths. And in the exam, guys, please don't trust yours as well. Even when you see that 1 plus 1, or rather when you know that 1 plus 1 is 2, please type it into the calculator. You need to be sure. All right, and then we come back and find the second difference because we understand that a quadratic number pattern is characterized by a second constant difference. So when we say negative 8 minus negative 4, well, we simply get negative 4. And the same applies if we say negative 12 minus negative 8. So indeed, we do have it, the second constant difference. But remember, we want to find the next two terms. So how do we do that? Well, it's easy. I want you to realize that if you take the first term and add it to the first difference, it's going to give you the second term. Because 94 plus negative 4 is 90. Do you see that? Now, similarly, if you take your 90 and you add it to negative 8, you are simply going to get 82. So what does it mean? It means in order for you to get term number 5, you are simply going to take, what are you going to take? That's a very good question. What are you going to take? Because remember, this has to continue, right? So you have to have something like this, and you have to have something like that. Do you see that? Okay. But it's also going to continue. You have something like this and something like that. So here it's going to be term number 5, and here it's going to be term number 6. And this is the difference between term number 5 and 70. And this is the difference between term number 6 and term number 5, all right? Okay. But now, in order for us to get a term that is here, we need to use the linear pattern. So how do we use it? Well, if you say negative 12 plus negative 4, well, you're simply going to get negative 16. And here you get negative 20. Are you there with me? So what does it mean? It means in order for you to get term number 5, that's if you take 70 and you add it to negative 16. So what is 70 minus 16? Well, it's just going to give us 54. And then if you say 54 plus negative 20, well, it's just going to give you 34. So the next two terms are 54 and 34. But if this seems slightly difficult for you, you can skip this question and find the general term in the second one, and then use your general term to find the value of term number 5 as well as term number 6. Right. Of course, you're going to use the general term to verify the values that we got, okay? But here we understand it's going to be 54 as term number 5. And here we are going to have 34, right? So the question then is, how do we find the general term? Well, we know that our general term takes the form an squared plus bn plus c. So in order for us to find the value of a, that's if we take 2a and we equate it to the constant difference, the second constant difference, right? So this is what we say. And dividing both sides by 2, we find that a has to be negative 2. Well, that's fine. But in order for us to get the value of b, that's if we say 3a plus b equals the first term of the first differences. You don't say it's equal to negative 8. It's wrong. Right. But now we know that the value of a is negative 2, and we are looking for b, all right? Now, this is negative 6. When we take it to the right, it becomes positive. And negative 4 plus 6, it's just going to be positive 2. Then the question then is, how do we find the value of c? Well, it's very easy. If we take a, we add it to b, we add it to c, the answer has to be the first term of the quadratic pattern itself. So what is a? Well, a is negative 2, b is 2. So we are looking for c. It means c is going to be 94. Okay. So if c is 94, then it means our general term is just going to be 2n squared plus 2n plus 94. In fact, it's negative 2n squared. Sorry about that. So this is our general term. Let's test whether or not the general term works. So maybe we can choose to substitute term number 4, for instance, and see if we get 70, all right? So we go to our calculator and say, well, we have negative 2 into 4 squared plus 2 into 4 plus 94. And we definitely get our 70, so it means it works. So now to verify our term number 5 and term number 6, then we are simply going to substitute a 5 there. And we get 54, which means it's correct. And for term number 6, we get 34. So it means these two are actually correct. So you now have two ways of finding the next two terms. It's either you use the first and second differences, or you begin by finding the general term and what? And using that general term in order to substitute the positions. Yes. Right. So let's look at this delicious question. It's very delicious. Now here they say to us, Calculate two consecutive terms whose first difference is negative 136. In other words, these two consecutive terms, successive terms, those that follow each other directly, are in the quadratic number pattern. That is what they're saying to us. So let's go ahead and analyze this one and easily destroy it. So I'm just going to clear this part. And I'm going to write the general term here, just in case we can need it. In fact, we will. So our Tn equals negative 2n squared plus 2n plus 94. Awesome. And I'm going to eliminate it here. Right. And I'm also going to get rid of these two terms. So this is what is happening, guys. We don't know which terms are there in the quadratic pattern, right? We don't know it's which terms. It's what we are looking for, right? But this is what I want you to know, or rather to realize. If you go to your quadratic pattern and say term number 2 minus term number 1, you're going to get term number 1 in the linear pattern. I'm not lying. 90 minus 94, it gave you term number 1 in the linear pattern, which is the first difference, right? Now, similarly, if you say term number 4 minus term number 3, you're going to get term number 3 in the linear pattern. No, it's not a lie. 70 minus 82, it gave you term number 3 in the first differences. Where am I going with this? Well, I want you to know that a certain term that we don't know, which is term number n, minus the term that comes before it, which is term number n minus 1, it's going to give you term number n minus 1 in the linear pattern. Do you get what I'm saying to you? Okay, fine. What is the significance of what I'm telling you now? Well, it's because somewhere in this linear pattern, we are going to have a term that has a value of negative 136. Do you get that? So what we need to do here is to find the values of these two terms whose difference has a value of negative 136, right? So what we actually need to do here is to find the position of a term in the linear pattern that has a value of negative 136. Okay, so how do we find the position of such a term? Well, it means we need to find the general term of the linear pattern first. So we tell them that you are focusing on the linear pattern, or you can say we are focusing on the first differences. It's up to you which language you choose to use, but I'm just going to stick to the first one. So, well, here we already know that the constant difference is that, so we can say Tn equals negative 4n plus c. And in order for us to find the value of c, you can either substitute term number 1 or term number 2. It's up to you. But if we substitute term number 1 there, the value of term number 1 is negative 4. But of course, it's at position number 1. So this means the value of c is going to be 0. Even if you use term number 2, because term number 2 is negative 8, and here you're going to say that and say plus c. This is still negative 8, And negative 8 plus 8, 0 as well. So, yes. So now that we know our C is going to be 0, then it means the general term of the linear pattern is just going to be negative 4n. So now that we know the general term of the linear pattern, then what are we going to say? Remember, we want to find the position of a term that has a value of negative 136. Okay, so this is as we say, well, negative 4n is equal to negative 136. And if we say negative 136 divided by negative 4, well, you find that n is just going to be 34. So it means the term that is at position 34 in the linear pattern is going to have a value of negative 136. So what am I trying to say in simple language? Well, I'm saying to you, if you take term number 35 in the quadratic pattern and you say minus term number what? Term number 34, it's going to give you term number 34 in the linear pattern. That's the significance of what I was trying to tell you. So what am I saying to you in short? I'm saying we need to find the value of term number 35 as well as term number 34. Those are the values whose difference will give us negative 136. Do you see how to analyze that? Of course you do. So we go and say, okay, fine, we want to find term number 34. So it's negative 2 into 34 squared plus 2 into 34 plus 94. And let's see how much we get. So, well, the value of this one is negative 2150. What about term number 35? Well, it's just going to be negative 2286. So now you can conclude and say, therefore, term number 35 and term number 34 will have a difference of negative 136. Over and out. So we still have one more question to destroy. And it's the last one. It's very delicious as well. And it counts for 5 marks, imagine. So here they say to us a quadratic number pattern has a general term Tn equals an squared plus bn minus 15. Oh, they give you the value of the constant, but not a and b. In order for you to find a and b, this is how they assist you. They say, if you take term number 1, you say minus term, in fact, term number 2 minus term number 1, you get a 3. And if you say term number 3 minus term number 2, you get 7. So please find the values of A as well as B. Okay, fine. No, these people are very intelligent, but they are not aware you are more intelligent than them, which is nice. So I want you to realize that we are not given the values of the terms in the quadratic pattern, but we know that here we have term number 1, And here we have term number 2. And this is term number 3. They only gave us 3 terms. But this is what they say to us. They said, if you say term number 2 minus term number 1, you get a 3. But if you say term number 3 minus term number 2, you get 7, right? And what we know about a quadratic pattern, it's that it's characterized by a second constant difference. So 7 minus 3, you get a 4. Yeah. So now we need to find the values of A and B. Well, it's now easy because we know that we take our 2A and we set it equal to what? To the second constant difference. And now we can find that the value of A is just going to be 2. Why is it 5 marks? These people. And then in order to find the value of B, we just say 3A plus B, and this is equal to 3. So since we know that the value of A is 2, and 3 by 2 is 6, 3 minus 6, it's negative 3. So these are the values of A as well as B. I don't know why they decided to say it's 5 marks. I'm not entirely sure. But there's nothing that you are supposed to do other than what we did here. No, there's nothing that we need to do. Of course, there's nothing we need to do. So, no, it's supposed to be exactly like this, guys. I don't know. Maybe they felt like giving you 3 marks, or maybe they're going to mark this portion here. Well, I'm not entirely sure, but those are the values of A and B, and you should be happy.